Hello and welcome to another edition of MathCast. This is Sarah Scatterplot
And I'm Emma Excel. Now, if you've ever gone to high school, you probably remember your daily trek to class. It could have been feet, yards, miles, light years away. Whatever the distance, everyone has to get to school some way or another. So what factors into the distances of students' commutes?
We decided to look at the relationship between household income of students in our class and the amount of time it takes them to get to school.
We thought this data might be interesting to look at because of Portland's demographics. The Grant area and its surrounding neighbors are high income. The median household income of the Grant neighborhood is $89,821. Neighborhoods further away from Grant tend to be lower income. We wanted to see if our class data would reflect this trend.
We predicted that students who took longer to get to school had low household income. Our thought process was that if a student takes a long time to get to school, they likely live far away from Grant. And in general, the further away from Grant you go, the lower median household income gets.
In addition, students who come from higher income families are more likely to have a car, making their trip to school much shorter than a student who walked the same distance.
So, our research led us to believe that there would be a strong relationship between income and commute to school time.
But as soon as we created scatterplot of our class data, we realized this wasn't the case. We were wrong. A scatterplot of our data had points that were scattered completely randomly, and upon adding a trend line, we saw that the trend line hardly had any slope. The data is so scattered that it would nearly be impossible to draw an accurate trend line.
The intercept of our scatter plot showed that when a student lives 0 minutes from school, their income is predicted to be $127,756, which is much higher than the true median in the Grant neighborhood.
When we calculated the median of our class data, we found this number was also larger than the median of the Grant area. Our class median income was $100,000.
Our slope showed us that for every minute longer it took students to get to school, their household income increased by $407.38. And this is the complete opposite of what we expected in our original prediction.
But the correlation referred to as R in the math world was so weak that the slope likely does not prove anything. The correlation coefficient R is 0.039871, making the correlation strength very weak, or having no correlation at all.
R squared tells us the percent of change in one variable caused by the change in another variable. Our R squared value was 2%, meaning that only 2% of the change in time it takes students to get to school is caused by the change of income in each student.
So all in all, the data from our peers did not prove our hypothesis to be correct.
But that doesn't mean it couldn't be true. A number of factors could have affected our findings.
Small sample size,
Different modes of transport.
inaccurate student answers.
If we were to redo this experiment, we'd collect data from a larger group of people, and we would measure the distance to school in miles instead of travel time. Although our data did not suggest that family income causes students to live farther away, we believe that this would be true if we had a larger test group.
This has been another edition of MathCast. Thanks for tuning in.